Hello all and welcome back. So in this video, let us now move forward and discuss about the time complexity of the check BST approach function which we wrote. So pretty sure that you must have tried the same. Now, if I talk about the complexity, let us first see that what are all the operations which we are doing. Okay. So in my check BST function, let me just close this as well. Yeah. In my check BST function, I am finding first the left max. Okay. Then I'm finding the right minimum. So I am in a way calling on the left and the right subtree to get me the minimum and the maximum. So some k and n work I am doing. Okay. Then I am doing left BST and right BST. So let us try to write this down, everyone. Let us say if our tree is something like this. So the way we think in recursion, if our tree is something like this, what effectively are we doing? We are saying that t of n is going to be kn. That is to find the minimum and the maximum, right? So I am going to each and every node to find that minimum and maximum. Plus, I am calling n by 2, right? So this is what I'm doing. After I have founded the maximum and minimum, I am calling the same problem on the left and the right subtree, right? Again, we have seen this a lot of time. The complexity comes here, something of the order n log n, right? What if I treat something like this? Let's say it's a skewed tree. So now that we know the name of this particular tree, right? Let's say it's a skewed tree. In that case, we saw that how t of n will be equal to, we are again doing some kn work to get the minimum and the maximum, but we will be making the call to a smaller tn minus 1 or n minus 1 tree, right? In this case, we saw that how complexity is n square. That means in the worst case, my tree, or sorry, this function is having a on square complexity, which we all know that it's little bad, right? Now let's see why is that happening. Okay, and it is exactly same as the way it was in diameter. Okay, so if you remember in diameter, finding the diameter of my tree, same kind of thing or analysis we did. The problem is happening. So let's assume that this again is a tree. So let's say this is a binary search tree. Okay. In this, what exactly is happening is that I am first asking this particular node to get me the maximum, right? That is what I make the call left max. And this I'm asking for the minimum. Now this proper node, what it does, this left node, it will be going to each and every of these nodes, and it can be at any depth to find out your maximum. Okay. And then returns the same. Similarly, this goes to all these nodes to find out the minimum and returns the same. Right. Once that is done, then I ask it again that, hey, get me if you are a BST or not. And the right side again, I make this call if you are a BST or not. Now, if you see what effectively we are doing, this node, the node which is on the left, right, this particular node, what it will have to do, again, it will go and find out that what is the maximum here. Okay. This will also again go and find out that what is the minimum in some part, right? For a tree which is a lot having a very high height, okay, which is a lot more complex, this overall operations will be repeated a lots of time. Same analysis we have done in the diameter code, right? Where we saw that how we are asking for similar things, okay? And if my node would have an idea, like if this node would have an idea that I will be asking for the isBST and the max, okay? And isBST, this node will also be requiring because it need to make sure that it should be smaller than the max on its left. it could have saved the same thing, right? It could have used that approach, that particularly to get you the answer. So the understanding is the same. What I'm going to do is I am going to say to my function to bring me things which I require, right? So let's say this is the left subtree and this is the right subtree. Now what effectively I want is that my function returns me the max here, and if it's a BST, and min here, and if it's a BST, right? That is what I effectively want. But we know that it is not possible because see, if we have written a recursive code, if we are calling the same function, then it is either going to give you the maximum or the minimum. Okay, so I will repeat what I'm saying. All I'm saying is that you cannot say that, hey, I want max from this side and min from this side. That is not possible. That is not a logic which you can write. Your function is going to return you things and it can either be max or minimum, right? So in this case, what we will have to do, we will have to ask for three things: min, max, and SBST. Okay. Once I have these three things, then what can I do? I can just use all of them. Okay. So from this particular tree, I'm going to take this max. From this, I'm going to take the minimum. Okay. And the conditions which I have to check are again going to be the same. So root dot data should be greater than max of left. Okay. Max left. Root dot data should be greater than minimum of left of right, and along with that is BST left, okay, and is BST right. All these things should be true, right? And along with that, I have to also make sure that I return. Okay, so what I have to return, this is going to be my answer, which I'm going to return. Along with this, I have to make sure that I return the right value for maximum and minimum. So how will I make sure of that? I will return, let's say first we are returning this answer, if it is BST or not. Along with that, I will return the minimum. Okay. So what is the overall minimum of this? It's going to be left minimum and node data, right? Or the root data. And I have to, let's say, return the maximum. So the maximum is going to be right max. Okay. So max, related right max only. Right max and the root data. Okay, everyone. So I hope this is clear as well, that what are the values which we have to return. Now we have to make sure that we are returning the right things. If it's a BST, then I'm saying either the node will be the minimum or it will be on the left or towards the right. We have to just check for that value. If we are returning these things, then we can be sure that each and every condition is checked. Okay. And the same complexity which was coming out to be on square in worst case, we will just reduce to on, because we will now just be calling and doing some work on each node once. Okay. So now what I want you to do is that I want you to write this particular function and I will provide you with the solution. So def check BST better. Okay. So in this code overall, you are going to complete this function. One more thing which I forget to discuss. If the root is none, then you can return true. Okay. For minimum, you will return infinity, and for maximum, you will return negative infinity, right? So that's the base case, which I've also helped you now. So you have to make sure that you code this function and then understand how the complexity is coming on from on square. Okay, everyone. So I hope this is clear. It is exactly same the way we did for diameter. Just that I want you are comfortable in handling these cases and making your code a lot optimized. Okay. Because the same is going to help you tomorrow a lot in any interview, in any contest or anything. If you're comfortable with this approach of optimizing the code, it's a lot helpful in writing an overall better code. Okay. So cool, everyone, do give it a try. I will be attaching the solution as well, which you can refer. But I will overall assume that you should be able to do it properly because we have done a similar kind of problem before as well. Okay, so do try it and make sure that you're able to do that as well, no matter how much time it takes. Okay, so let's meet in the next video. Thank you.